Let's explore the different types of databases and when to use each one. First up, relational databases. These are the workhorses of the industry. PostgreSQL, MySQL, SQL Server, Oracle. They all follow the same core idea. Structured tables with rows and columns linked by foreign keys. They're ACID compliant, meaning your transactions are reliable, perfect for banking, e-commerce, and any system where data integrity is non-negotiable. If you need complex joins, strict schemas, and battle-tested reliability, relational databases are your foundation. Next, document databases like MongoDB, CouchDB, and Firestore. Instead of rigid tables, they store data as flexible JSON or BSON documents. This makes them ideal for content management systems, user profiles, and real-time applications where your data shape evolves frequently. They scale horizontally with ease, which is why they're the go-to for startups and mobile backends that need to iterate fast. Key value stores are the simplest and fastest database type. Redis Dynamod Memcached. They map a key directly to a value. Think of them for session management, caching, shopping carts, leaderboards, and rate limiting. Anywhere you need sub-millisecond lookups. Redis can even run entirely in memory, making it blazing fast for real-time use cases like feature flags and counters. Wide column databases like Cassandra, HBase, and ScyllaDB organize data into column families rather than traditional rows. They're designed for massive write, throughput, and horizontal scaling across multiple data centers. This makes them perfect for time series data, IoT sensor streams, event logging, and analytics pipelines where you're writing millions of events per second. Graph databases like Neo4, Amazon Neptune, and Arangob are built for connected data. Instead of tables, you work with nodes and edges, making relationship traversals incredibly efficient. They shine in social networks, fraud detection, knowledge graphs, and recommendation engines, anywhere the relationships between data points matter more than the data itself. Search engines like Elasticsearch, OpenSearch, and TypeSense aren't traditional databases, but they're essential in modern stacks. They use inverted indexes to deliver full-text search, autocomplete, and relevance-ranked results in near real time. You'll find them powering product search, log aggregation, monitoring dashboards, and geospatial queries. Time series databases are optimized specifically for time-stamped data. InfluxDB, TimescaleDB, and Prometheus are the big names here. They handle high-frequency ingestion, automatic downsampling, and retention policies out of the box. If you're tracking server metrics, financial tick data, or IoT sensor readings, a time series database will outperform a general-purpose one by orders of magnitude. The newest category, vector databases. Pinecone, Weaviate, pgvector, and Milvus store high-dimensional embeddings. They power semantic search, RAG pipelines for LLMs, image and audio similarity search, and recommendation engines. As AI applications explode, vector databases have become the critical link between your language model and your data. So how do you choose? Here's a quick decision guide. Need ACID transactions? Go relational. Flexible schemas. Document stores. Sub-millisecond latency. Key value. Massive write throughput. Wide column. Deep relationships. Graph database. Full-text search. A search engine. Metrics and time data. Time series. AI and embeddings. Vector database. In practice, most real-world systems use polyglot persistence, combining multiple database types, each playing to its strength. The key is matching the right tool to the right problem.